Okay, and we're back for part 2. I hope you guys are still doing well, and we're going to start out here with the nature of static electricity. So, what exactly is going on? Let's not worry about this down here at the bottom right now. This picture, this will come into play later, but when people started studying electricity, they thought it was an invisible fluid. Benjamin Franklin actually thought this as well. He said that the object was filled with electric fire or something like that, like this invisible fluid type substance. And it's because, as many of you guys know, it's very difficult to catch a spark on camera or to actually record one. Nowadays we have much better technology. Back then they had no idea, so they didn't really see it. We got a real answer when electrons were discovered, and so now we're going back to the subatomic particles that we talked about earlier on in the year. And the electrons really helped us to understand exactly what is going on with static electricity. So, electrons have a negative charge and protons have a positive charge. This should all be stuff that you guys already know and remember, and it is still very important. Just like I told you guys when we did this, you're going to see this stuff come up a lot, and it is going to affect your whole science discovery until you even get out of college. Some of you might even go to do master's degrees where you'll have to still remember this. Here, electricity, what we call electricity, is actually the interaction between electrons and other charged particles. That is where we get our electricity from. And we've gotten so good at using electricity that we are actually able to manipulate it to a way that we can store it and we can put it in different things, which is why I wanted you guys to really concentrate and think about what we were talking about when it came to those electric machines. Really awesome stuff. Now, looking down here, I just want to show you guys something else. See, when you have a positive and a negative charged particle and they come and they meet together, more than likely this negative charged particle is going to be an electron and this positive is going to be a proton. They will actually neutralize. And then when you have two positives, they repel each other. And when you have two negatives, if it goes away, you can see that it does repel. And so that is something to once again write down in your notes, or to find that picture and throw it in your Google Docs, whatever it might be. It's really up to you guys. So just want to make sure I see those notes, and I want to make sure you guys are taking notes on these videos. From there, we also get into the nature, some more, of static electricity. So it says an atom with an equal number of positive and negative charges is called neutral. And that's because, well, that's actually where we get the word neutralize from. And so if you look down at the example below, you can see that if you count, there's 1, 2, 3, 4, 5 negatives in there, and 1, 2, 3, 4, 5 positives above the neutral box that you can see right here. And so, therefore, it is neutral. When you go to the next one, it is negatively charged. You count the positives. 1, 2, 3. 3 positives. 1, 2, 3, 4, 5. 5 minus 3 is 2. And you have a negative 2 charge. And then the one all the way over on the right, that is positively charged. You can count those up there, and you can see there's 3 more pluses than there are minuses, making it positively charged. And so we have neutral, negatively charged, and positively charged, all there for you guys. This is a good thing to write down in your notes as well, and it helps out with a lot of stuff we're going to talk about later on. Seeing here, when equal and opposite charges come in contact with one another, they actually will neutralize, or they will become neutral. That's what's going on here in the first one that you see all the way over to the left. Equal amount of positive, equal amount of negative, they neutralize or become neutral. That's where the word neutralize comes from. It means to become neutral in that sense. Now, going here, we're going to talk about some static electricity, and I got some really cool examples down at the bottom. Bottom left, you see Garfield. Garfield is an awesome comic. Has a lot of really funny stuff in it. And you can see that Garfield himself is becoming electric. He is going across the wool floor inside his house, and he is getting a lot of static electricity, and then he goes in back of John, he just like zaps him in the back. Now, the example on the left is actually a bit more interesting, and you can see this a lot when you guys go to the park. With the right conditions, young children's hair will actually start to stand up, and that's because they are becoming electrically charged and their hair is trying to kind of discharge at the environment, and so it makes it stand up and do all kinds of weird things. Some of you guys actually have older TVs you can do this with. If you stand close to an old TV, your hair will be attracted to the TV and will actually, you know, if it was laying down before, it'll just like stand up to go get toward where it was. That all has to do with discharging electricity, static electricity. Now, looking here, it says when an object is electrically charged, its electrons do not really go anywhere. And so when you give it that electrical charge, that one object, its electrons kind of just stay in the same place and they build up. This is why it is called static electricity. And so they don't go anywhere until you actually do something. And so in this case, if you look at Garfield, it's when he actually goes and he touches John and his charges become neutralized in that sense. From here, static also comes from the word that means stationary or unmoving. So that's why we call it static electricity, and it all has to do with the idea that the electrons aren't going anywhere. And so we say they are static. That is where we get the idea of static electricity. I believe that's the... Oh, here we go, one last one. So static electricity is often generated through friction. This is why Thales was able to make his experiment work. When he got the amber and he rubbed it across the wool, that's why it worked the way it did. It all had to do with that static electricity. Very, very cool stuff. And I believe that is the last slide that we're going to go over today. And so you guys had a lot of notes there. Hope you guys are taking them down. Hope you guys are really thinking about this stuff here. And there is going to be an assignment that's going to be put up on your Google Classroom that you need to go and you need to finish before the end of the day. And so I just hope you guys are having a wonderful day. I hope to see you guys very soon. Hopefully this whole thing will blow over sooner rather than later. And I will see you in a video tomorrow. Goodbye.